The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for coming out to our webinar on industrial solutions. If you have any questions or comments, please type them into the text box on the right. And without further ado, here's Bruce Collins.
Thanks, Alan. This is Bruce Collins. I'm a product manager with Cambium Networks, and I want to thank you all for joining today. We're excited to be announcing a new platform in the Cambium portfolio. This platform is called cnReach, and I'll get to the many more details on that as we go. As was mentioned, you can put your questions into the chat window, and we'll have plenty of time for questions at the end. But certainly, if you have a question that occurs to you during the presentation, go ahead and put it in there, and we'll try to answer them as they come in where it makes sense. So I'll jump right into it. I'm going to give you a high-level overview of how Cambium solutions fit into the industrial Internet of Things space, and then we'll talk specifically about the new products. So Cambium Networks has been in the industrial space for many years, and you'll see a lot of discussion in the press about the Internet of Things and more narrowly the industrial Internet of Things. And one thing it's worth stepping back and looking at is to say, well, we're delivering solutions to the industrial verticals today and have been for some time. And those applications are things like you see on the left here, SCADA data solutions, controls and sensors, remote office access using our Wi-Fi hotspots, the ability to deploy remote access into remote areas. Video surveillance and security is certainly a central tenet of our capabilities. Lease line replacement, being able to move from public networks over to private networks and therefore reduce the monthly operational expenses that are associated with those subscription services and move to a model where you're completely in control on a private network. And then supporting the metering infrastructure. And what a lot of these applications have in common and across all of our products is we're really going after solutions that have a wide geographic area, lots of points of presence, and the need to move or transport data confidently and confidentially, so reliably and securely across that wide area network. And the other thing you'll see is when you hear in the press about Internet of Things, you'll hear everything from Apple Watches to being able to automate retail operations and hospitals, but we're really focused on these areas where we have the experience and are frankly good at, which is these heavy industry spaces such as electric utilities, oil and gas, water, wastewater treatment type of operations, and then also into the rail and intelligent transportation areas where we can provide train yard automation, positive train control, intelligent traffic solutions for large highway systems. So we're really thinking in terms of heavy industry that's covering outdoor spaces. Examples of that I'll show you here is the electric utility. This is sort of a high-level schematic view of a network that starts with the electrical generation, whether it's coal or nuclear, distributing that over the distribution portion of the network out to the remote substations, and then from substations down to metering at both residential and business and industrial. And what you'll see is these bubbles of application where we can provide solutions from Cambium. And if you start with the green lines, that left line, that's a licensed microwave ring, so you might imagine a multi-gigabit per second ring that's covering a wide area. And then the spurs off of that might be additional PTP 820s. They might also be PTP 650 or PTP 450i. These are capabilities to provide that backhaul out to individual areas. And if you look in the lower right, then you could extend that further with a point-to-multipoint solution to deliver out to, say, backhauling smart meter gateways. And what we're introducing today with cnReach is the ability to further extend those applications and talk particularly to RTUs and PLCs, talk to sensors that might be at those substations, and transport that data back to the NOC where the process control and monitoring can take place. So we see this as an extension of what we're doing today and allowing us to serve electric utility operators with a wider set of functionality. Similarly, if you look at the oil and gas and petrochemical industry, there's a need for many of those same applications. And if you look at the green bars in the diagram below, it's many of the same applications. It's point-to-point for backhaul, multi-point for video surveillance, and now with our narrowband solution with cnReach, the ability to do SCADA process monitoring and control. But ultimately, the transport technology is very similar as we move from the utility space to the oil and gas space. And then if I also show you here an example of water and wastewater treatment facilities. Again, you'll see very common themes across this, which is high-capacity rings, high-capacity backhaul, multi-point for access, and then narrowband for the critical infrastructure process control. And this kind of results in a chart like this, which has all of our products that contribute to industrial IoT. Starting at the left, you have the PTP-820 that does licensed microwave. We have our 650 and 450i in a variety of spectrum that's doing sub-6 gigahertz backhaul for near and non-line of sight. We have the 450i platform for access, aggregation of gateways and video surveillance. We have our CN Pilot product, which especially with the E500, which is a rugged outdoor 802.11ac hotspot. And then what we'll introduce and discuss today is the cnReach N500, and that's for narrowband control and monitoring, and initially in the 700 and 900 megahertz bands. And what you see across the top of that table is what ties all of these together and makes for an end-to-end solution. We have our CN Maestro management solution that provides a single pane of glass view into what's happening across the network. So whichever of these sleeves of products that you choose to deploy, you can manage what's happening with those. You can see on a geographical map. You can see on a hierarchical view of what is the end-to-end path from where the bit leaves the NOC to where the bit arrives at the sensor. And you can do troubleshooting and fault management as well from a single view. And then similarly, we have our link planner planning tool, which is useful for doing a couple of things. One is it can tell you where can I achieve connectivity from point A to point B. What's the best technology to select? So I can, within the same link planner tool, I can say, well, should I use a licensed microwave? Should I use unlicensed point-to-multipoint? Should I use a narrowband cnReach? So I can do these trade-offs and what-if scenarios between the different products all within the same tool. And then Link Planner also generates a complete design document, proposal document, and bill of materials for identifying exactly what's needed to deliver that solution. So with that as sort of a backdrop in how the Cambium's IIoT portfolio fits together, let's talk about the narrowband solution itself. If I step back and look at those different verticals, the applications that we focus on with cnReach are sensors and automation for the oil and gas utility, distribution, substation automation, again, monitoring and control and sensors in the electric utility space, and then again, sensors for water and wastewater. Now, the application and use of cnReach is to transport the data from the sensor back to the NOC or back to the control center. So we're not, Cambium is not in the sensor business, but we're in the transport business to make sure that the data as it exists in all these different islands around a wide area network in a large geographic area, we are able to provide the transport or the data pipes back from those remote areas back to the central location. And to give you an example, here's a very simplified view of an oil field, and you can see in the upper left, you see sort of a network topology that shows point-to-points and point-to-multipoint links, all connecting over a wide area network back to, in this case, a SCADA master. Out in the field, in the remote areas, you have things like wellheads where you're pumping, batteries where you're storing the equipment, and then different separators and flares. And each of those devices has a number of sensors on them that need to be monitored. So, for example, you want to monitor pressure and temperature, and you want to be able to tell which hatches or doors might be open when they're supposed to be closed. And then you can also turn off valves and pumps and make sure that the operation is done in an automated fashion. And what we're able to do is with a lot of different connectivity options, bring that information back to the SCADA master. And the traditional application is for process control, monitoring and control. What we see with all of the new capabilities coming from the data engineers and data scientists is additional analysis that can be done in these environments. So we're finding that there's even more need to instrument more locations, in some cases to support some of the analytics that are coming down the roadmaps from the different companies that are doing into that space. We do get some questions. There's a lot of text on this slide, but we do get some questions. Well, how does cnReach fit with networks like the LoRa Alliance, some of the proprietary public networks like a Sigfox or an Ingenue, and then how does it fit with some of the for a carrier network using 3G or 4G as a wide area solution? We're definitely on the private network side. So cnReach is designed to be a set of equipment that an industrial organization purchases and deploys as a private network and secures and manages and maintains as a private network, rather than building out a network and selling access to that network. So that's sort of the fundamental difference when we talk about private networks versus public. So some of the trade-offs you get with that are, on Spectrum, we have both licensed and unlicensed products. So you'll see in cnReach the ability to run this in a licensed spectrum, so the organization can go out and get exclusive access to frequency to minimize any kind of interference. We also have unlicensed spectrum products that have very good interference tolerance in being able to operate in those unlicensed bands, where many of the current discussions around LoRa are using unlicensed spectrum, and certainly the carrier networks is all licensed. The coverage area, the public networks are going to generally be opportunistic, and they're going to deploy coverage where there's large population densities and large densities of industrial organizations that are closer to the population centers, where a private network in those very remote areas that we're going after needs to be kind of a bespoke deployment scenario, where I'm going to figure out what are those remote areas I have to connect, and I'm going to tailor a solution to those areas. Availability, generally a private network is designed to deliver critical infrastructure, meaning I need to be able to know if it's time to throw that switch. I need to make sure that that signal and that command is going to make it out across the network. Whereas a more traditional LoRa type approach is for metering and consumer type applications. And maybe I'm going to pull a device every 24 hours, and if I miss that pull, it's not really a problem to go out there and get that information the next day if I happen to miss one. So there is a very difference in the availability requirements. Funding is clearly different. With a private network, you're generally going to have an upfront capital expense versus a recurring operating expense with a public network. And that leads kind of the next one, which is devices, where I need to with a private network, I can buy it once. If it's a public network, I have to keep track of those devices. I have to understand when those devices go out of service, so I stop paying those subscriptions. So there's a lot of a whole additional level of overhead in device management when I'm working with an OpEx model. And then, of course, capacity. Just like coverage can be scaled or tailored to the requirements, capacity can be tailored to the requirements as well. And last but not least, security. Many of the oil and gas space, and certainly electric utility with NERC CIP compliance, have very specific IT and information assurance requirements. And maybe it's not always the same, and maybe certain areas of the network you have to have much more locked down security certificates, password controls, user access, and maybe it's less important in other areas. So you can kind of tailor the security configuration in a private network to the actual application. And oftentimes security and convenience are sort of a trade-off that needs to be made. The more secure the network is, the less convenient it is sometimes to use. So you can kind of tailor that to what the application requires. So let me introduce cnReach. This is the new narrowband platform. Some of the criteria that we looked at with this product in addressing those applications I've been discussing in the first few minutes here is we looked at a number of criteria. We looked at deployment flexibility. So we want to be able to take the same module and deploy it as either point-to-point, point-to-multipoint, traditional store and forward, or what I'll talk about in a bit here is an advanced store and forward where I'm actually using a dual radio. We know that some customers want to put optional digital analog I/O, so we have that built into the radio as an option. Supporting both licensed and unlicensed in the same product gives some additional deployment flexibility so that at least in the US, I have the option of starting out with 900 megahertz, the ISM unlicensed band, and then migrating over to the MAS band if and when I have access to licensed spectrum. For reliability, much like our other industrial products, like PTP650, we do test cnReach 100% over temperature, so every unit is tested at both very cold temperatures, neg 40, to very hot temperatures at neg 40 C to plus 60 C, and functional testing is done, meaning we connect in pairs of radios and make sure that these radio modules themselves actually connect at all the different temperatures. For the oil and gas market, we have ATEX HAZLOC. This is the ability to work in intrinsically safe environments to prevent hazardous situations, and the product is manufactured in the USA. Low power consumption, this becomes important in certainly very remote areas where I might be looking at solar applications, might be looking at the ability to do battery backup. So this radio, depending on the duty cycle and depending on how often you're pulling it, is on the order of just a few watts of power consumption. And then scalability, especially in the 900 megahertz ISM band, we have the ability to do access point synchronization. So using our UGPS module, we can synchronize multiple access points using a GPS signal to deliver a very precise 1 pulse per second reference signal. We can lock the access points into making sure that they don't try to transmit at the same time on the same frequency. In the unlicensed band, 900 megahertz, this product is a frequency hopping spread spectrum radio, which means it's continuously moving from one subchannel to the next. And by synchronizing the way that those multiple access points step through the different channels, we can minimize self-interference. The product supports adaptive modulation, which effectively means I can have a radio that's near, in a point-to-multipoint situation, I can have a radio that's near the access point operating at a higher speed, and then a radio that is further away might have, or maybe it has more foliage or more obstruction in the line of sight, can drop to a lower modulation. And so I'm going to maximize the efficiency or maximize the use of the over-the-air spectrum. The product is, as I mentioned, security is important. That kind of comes from our heritage coming out of Motorola Solutions, working on public safety applications. It also is a factor in our national defense and military markets. All of those features that are required for security get baked into new products, and this product has, for example, the 128 and 256-bit encryption and password control, and you'll see incremental improvements and ongoing advancements in security as the entire industry moves forward on cybersecurity initiatives. And then last but not least is manageability. And I talked about both cnMaestro and Link Planner as being able to do that. So there's two different bands. The first band we'll talk about is the 900 megahertz narrowband solution. This is the same radio module can be deployed in either the MAS license band, and you can see that 928 to 960 megahertz, or through a software configuration I can swing that over to the ISM unlicensed band. So again, I can start out unlicensed and later on move to licensed. You'll see the transmit power is up to 3 watts on the licensed side, and it's limited to by the FCC on the unlicensed side, but it can go to the maximum of 1 watt. This is definitely what we refer to as a narrowband solution, which allows you to go long distances with high system gain and high receive sensitivity, so you have very reliable signals. And we're talking about up to 210 kilobits per second on the MAS license band, and then with unlicensed up to about 4.4 megabits per second. We'll talk about some of the I/O capabilities here in a moment. So similar to the 900, we have a 700 megahertz narrowband radio. This is a licensed band product. It has 2 1 megahertz channels in the U.S. From 757 to 758 and 787 to 788. These are licensed band products that have typically been used by electric utilities, but are available to critical infrastructure operators through subleasing from the owner of that spectrum. This product does up to about a megabit per second, depending on the channel size that is licensed. And again, long distance security is consistent across the platform. The deployment topologies you can see in the top is point-to-point and point-to-multipoint. On the bottom, what I'm showing is that sort of advanced store and forward repeater capability, where I have in the radio second from the left, there are 2 radio modules in there. So you can imagine a relay node that needs to point both east and west. A traditional store and forward repeater would have a single omni at that point and would, in sort of a bucket brigade fashion, listen on the east side and then turn around and send that data to the west side. What we're able to do with cnReach is with a dual radio configuration, I can be transmitting and receiving in both directions at the same time from a single module. And then similarly, in the radio third from the left, you'll see a point-to-point backhaul followed up with a integrated multi-point. So think of that as essentially as a self-backhauling access point. One of the areas that's important when we talk about process control and monitoring is the additional connectivity. Many of the applications in these heavy industries are coming from a series of legacy equipment that might be based on serial interfaces or even voltage levels for that need to be read as a switch contact closure or a voltage level coming directly off of a sensor. So in the interest of easing the migration from analog and legacy systems to all IP systems, cnReach has a significant amount of connectivity built in to allow that migration. So some of the things that you can connect using any kind of RS-232 serial port with a command line, serial bus sensors on a 422 or 45 serial bus, SCADA control systems by allowing the pass-through of DNP3 traffic and Modbus traffic, any kind of terminal server client interface that's using serial data. Certainly there's, as we migrate to all IP networks, the ability to connect to anything that has using TCP/IP, and then analog and digital I/O signals. So a lot of different connectivity to build out these solutions, and then ultimately take that data and pass it over the air so it can head back to the NOC. Within the radio itself, the switching, the data capabilities, there's a switching fabric, so there's an integrated Ethernet switch with layer 3 routing, so you can be very precise about what traffic goes over the air and what traffic stays local at that cnReach radio. You can also do, for simplicity, you can also deploy this as a completely layer 2 flat network. So you have a couple of options there. And really what the goal of the data fabric or data capabilities is to keep licensed and unlicensed traffic separate. I can try to reduce the amount of broadcast traffic that goes out over the air on narrowband channels. I talked about store and forward applications where I have a relay node and I want to make sure that data that's destined for a relay point doesn't go beyond that. It stays at that first hop. And then certainly sharing serial and IP networks as this migration occurs, being able to combine multiple data sources over a common pipeline. Here's a little bit larger picture of the radio and gives you a sense of the connectivity in the I/O. You can see on the front of the radio there's two 10100 Ethernet ports. There's two serial interfaces that can be 232, 422, or 485. On the picture on the top, you'll see two TNC connectors. This is the ability to configure one or two radios in the module. And then on the lower, or on the picture on the right, you'll see a little green bar on the left of the radio. That is a optional analog digital I/O port that I can have up to 8 individual pins that can either read voltages or currents or counters, or deliver or drive a particular voltage level, so I can again interface directly to a sensor if needed. I should also mention at this point that there is also a product that we call the I/O expander, and that's the ability to have all of this I/O and connectivity but without a radio. And so imagine this exact same module but without the TNC connectors on the right. That product is useful for adding additional I/O capability to a traditional Cambium, for example, a traditional Cambium PMP450i network. For example, if I had a multi-point network, broadband network that I wanted to add some serial devices to, or I wanted to add some analog digital I/O, I can add that to the network and then leverage cnReach, but then leverage the broadband capability to go over the air. A little more detail, there's a web-based management interface. So while I mentioned cnMaestro as the centralized overall management, you can do everything locally on a local web interface using either HTTP or secure HTTPS. There's a mechanism to distribute firmware over long periods of time, because if you think about these are narrowband pipes delivering connectivity to many of these solutions, we can schedule a software update to occur over, say, 24 hours or even longer period of time, where I'm going to push that out over the air in a broadcast mechanism from the access point. So the files might be 5 to 10 megabytes, and I'm going to slowly trickle that out to all of the devices, and then I can, once it's out there to those devices, then I can say, yep, it's time to go ahead and do that software update. And then similarly, I can do a file-based backup and restore my configuration, so I can store common configuration files and push them out to the remote areas. This sort of shows how cnMaestro fits into the overall architecture. You have the overriding network management and fault and performance management that sits on top of both our backhaul, our distribution, and now our edge products, which include cnReach and cnPilot. And here's kind of a early prototype of a graphical user interface for cnMaestro managing cnReach products. Again, this is a prototype. We're expecting to have cnMaestro integration available for beta testing in about 60 days, and that will show the ability that you see here on the screen, where I can have I'm actually selected on a cnReach access point. That shows me where that is in the geographical view of a map view of a network. I can see the historical throughput levels on that radio, what data has actually been driven through this portion of the network. I can see what clients that are hanging off of that access point and whether they are active or interactive or online or offline. I can see the hierarchical view. If you look at the left, I can see that this is fed by in this example, it's a point-to-multipoint access point. So that's, for this case, a PMP450i feeding a PMP450i subscriber module, and then a cnReach access point off of that. So it's just an example of how a hierarchy might be shown, and that allows the operator to very quickly see that if there was some issue with that 450i subscriber module, what devices are dependent on that product's capability or connectivity. And then on the right, you can see things like what's its current throughput capacity, a lot of the parametric data about that particular device, like the configuration of the IP addresses and what version of software it's on, a variety of those things, what frequency it's operating at. So I can kind of get a quick snapshot on a dashboard. And there's much more to come on Maestro, but this kind of gives you a flavor of how it works with cnReach and how it's integrated across the other platforms. And then Link Planner works in a very similar fashion to how those of you that might be familiar with how Link Planner is used for our PTP 650 products or our PMP 450i products. It works in a very similar fashion, where I start at the top left, I select the band I want to operate in, I select the product, I select some of the parameters or configurations around it. In this case with cnReach, you'll pick which modulations do I want to have active and enabled on that product, whether I'm going to use synchronization. And then it pulls a path profile from a centralized server, and it'll show you what is the terrain from point A to point B. And then I can edit that terrain by adding obstacles if I see those. I can do some nice back and forth interactions with Google Earth and see with KMZ files and see exactly what obstacles might be in that path. I can kind of do a virtual site walk or path walk to see what other issues might occur in that link. And then I can go further down and I can select which antenna I want to use to decide how much gain I'm going to get. And then ultimately what you're targeting is, at the bottom, a particular amount of capacity at a certain availability level. And once I start doing these trade-offs in channel band, channel sizes, frequency selection, antenna selection, I'll start to see the trade-offs in what-if scenarios on the performance summary, and I can design this in until it meets the necessary criteria. It's also worth pointing out that with cnReach, you get the entire capability of Cambium support. That includes this global sales team with both sales managers and pre-sales technical managers, as well as our inside sales team that can help understand product configurations and availability and different options that might be available. We sell cnReach through our connected partner Cambium Networks channel and distribution network. So we have lots of expertise in our different distribution partners, value-added resellers, and system integrators that can help help design these solutions. Many of those channel partners have gone through our or will go through our training program. We'll have certified engineers in cnReach, so we offer training and certification. We offer webinars like this on a regular basis on a variety of topics. Some of them are more technical in nature, some of them more solutions in nature. And then certainly our support center is available for picking up the phone and calling somebody or sending an email, and then we can escalate that to a Tier 3 engineering team that is co-located right here with our engineers and can help on any issues that require more complex analysis or troubleshooting. And then the product is available with a 1-year standard warranty and the ability to add additional warranty, as well as the ability to do what we call advanced replacement. So if you'd like to purchase an advanced replacement extended warranty that kind of covers more fault conditions, lightning or any other types of faults or failures that might occur, and we can send you a replacement unit in advance of your returning the original unit. So it's kind of a nice add-on to the overall system availability. So I'll kind of summarize and we'll move to questions. So if you have any questions before I summarize, you can put them on the chat window. Essentially what we're doing with cnReach is we're adding to our existing portfolio for industrial applications. We can cover connectivity from 2 meters to 246 kilometers. We do indoor and outdoor coverage. We're adding kilobytes or kilobits per second to our megabits and gigabit per second capabilities. So regardless of the payload requirements, we can deliver different capabilities. You can see lots of different topologies, scalable, secure, global. I should mention that cnReach, as we launch it this week, is targeted and available in North America, US and Canada, and that's at the 700 and 900 megahertz spectrum. We are going to very quickly follow this up with additional bands. So be interested in feedback from those of you that are outside of North America on priority of additional bands. Examples of that might be 400 megahertz, 200 megahertz, or 100 megahertz. We also have some possibilities with this platform in the above 1 gigahertz spectrum. But those are kind of the areas that we're looking at. I'll pop up a couple things here. Social media, we have different ways to get information about these products through our Facebook, LinkedIn, Twitter, various ways of getting new information. And then we just yesterday opened up a cnReach area on the community, the Cambium community, that you can ask questions and engage in conversations with other users of the product. And we'll be posting more knowledge-based content and articles about cnReach as the product rolls out. I should also mention cnReach is available for order today. It's available. It will start shipping. The 900 megahertz product will start shipping in early October, and the 700 megahertz product will start shipping in November. So product is information is available on our website, and certainly through your channel partner or Cambium sales contacts, and then also through the website, as I mentioned. So let's pause there and take any questions that might come up, and come back to a cnReach picture here so we can. Okay, good. I see a few questions on the line here, so let's take a look at those. So first question on here is, in the future, will it be available, will cnReach be available in other bands, particularly 2.4 and 5.8? So what I see today is, again, currently it's in 700 and 900, and as I mentioned, the candidate bands to go beyond this will be 400 megahertz, 200 megahertz, and then possibly the 100 megahertz as well. 2.4 is a possibility. Platform can support that. We don't have that on the short-term roadmap, but I'd be interested in the application. The other thing to keep in mind is the ability to mate the cnReach I/O expander with the PMP450i that's operating at either 2.4 or 5.8, and use the I/O capabilities of cnReach to deliver and to provide that serial and I/O connectivity. So that's another option at 2.4 and 5.8. There's a question about mesh. The cnReach is not a meshing product. It's a hub and spoke or point-to-point. So point-to-point, point-to-multipoint, and relay options with cnReach. How many digital analog I/O are supported? I don't have all the detail in this presentation. There's certainly more available. There are 8 different pins, and they're programmable in how they're suited for either input or output, and whether I'm measuring a voltage level, a current, or a count. So I can do quite a lot of flexibility with that, and that's all then readable using traditional Modbus type of application. So I can read the status of those digital analog I/O using Modbus protocols. There's another question for repeating endpoints. How many hops are allowed in an endpoint? So there's there's a difference here between sort of a theoretical limit and then sort of a practical limit. The practical limit is you're going to have in a repeating or repeater node, you're going to have shared capacity down that repeating site. So I would say the practical sense is sort of somewhere between 4 and 8. I believe the theoretical could go higher than that, but in practice I don't know that you go much beyond sort of that 4 to 8. Next question is around distances and near and non-line of sight performance. So with this, one of the key benefits of a narrowband solution is I'm transmitting and receiving over these very narrow channels. And you can see here, let me go to another slide here. You can see in this case on a license 900, I'm sending on either a 12.5 to 50 kilohertz channel. And what that does is it concentrates the energy over a very small piece of spectrum. So I get even better system margins or system fade margin, which helps both with distance as well as for foliage penetration. So I have a narrow channel. I'm at a low frequency. I'm below a gigahertz, so I get very good propagation through foliage, and then I can also, using relay nodes, I can go even further if I have to say go around a particularly massive mountain or something like that. So this will provide significantly better range and foliage and non-line of sight penetration than a traditional broadband product, for example. So that's one of the key differences when I talk about narrowband. Link Planner will show that difference in that delta. Link Planner supporting cnReach, we expect to have a version posted by the end of this month that you'll be able to do point-to-point planning with cnReach, and you'll be able to see the difference there in how the system behaves. Another question about does Link Planner work with an Apple or a Mac iOS? So yeah, Link Planner works both with Windows and Mac. I will say that for a variety of reasons, the Windows version is more featured primarily because of some of the licensing constraints on iOS and the ability to integrate with some of the mapping capabilities. So you'll generally see better. You'll get a better user experience on the Windows client-based version. So yeah, I appreciate all these questions. It's good. I'm going to keep going here. So another question about bandwidth. Will the product be available in a UHF 403 to 430 megahertz band? So that's one of the candidates to follow up this initial release with. So I would say that that's the leading candidate, and I would look for that in a relatively short term. So definitely I anticipate that that coming down the pipeline. So someone says, well, why would I consider cnReach versus a PMP450 in an oil and gas network? So really, it's a couple of different aspects to it. One is again that narrowband capability, so I can have the long distance through very difficult terrain and foliage. So I have a better system gain with the narrowband product. I have significantly more I/O capability, although I can add the I/O expander to a 450 platform. So I certainly have the ability with cnReach to extend the I/O capability at the subscriber modules if I happen to be choosing a PMP 450 or 450i. But I would say the big benefit is with cnReach is its ability to run in narrowband for better coverage and non-line of sight penetration, and then of course the ability to operate in the sub-gigahertz bands and particularly licensed bands. So the 450i, it is available in 900 megahertz. The channel size at 900 megahertz, the smallest channel size on a PMP 450i is 5 megahertz, and you can see here that the largest channel size on a cnReach is 1.2 megahertz. So this one, cnReach stops in increasing channel size well before the 450i even starts. So there's a significant difference in capacity, but I think you'll also see that in the system gain. There's another question here about is the MAS band using full duplex frequencies? So the product is not. It's a half duplex radio. It can use full duplex frequencies, meaning it can transmit on one half of a full duplex frequency allocation and listen on another, or you can configure a radio to transmit and receive on the same channel in half of a full duplex allocation. And that on the MAS license band, it's 3 watts power in the transmit power side. Let's see, there's a question here. So there's a question about the ISM 900 megahertz product. So the technology that in the unlicensed band, the radio is using frequency hopping spread spectrum. And what that means is it takes that traditional ISM unlicensed band, the 902 to 928 megahertz, and slices it up into a large number of channels based on the channel bandwidth. So you can see anything from a 76 kilohertz channel up to a 1.2 megahertz channel. Slices that band up, and you can tailor how wide that channel is and how wide the hopping range is. But the way that system then works is it starts on individual channel, and then through a configurable mechanism, you can either have it hop on a specific pattern, you can have it hop on a pseudo-random pattern, but essentially, again, depending on the channel size and the number of channels, the dwell time or the amount of time it actually sits on an individual channel is limited to a very a short duration. So it might be 60 milliseconds or so that it's going to sit on a particular channel, and then it's going to move on to the next one. So that's called FHSS, or frequency hopping spread spectrum, and that's in the unlicensed part. If I take that same module and I configure it to operate in the MAS license band, then it's going to operate in a more what we might call a more traditional on the broadband side, where I'm going to sit on the channel that's been allocated to me. and I'm going to do that send and receive, transmit and receive on that particular channel, and I won't be hopping in the license side. There's a question about getting access to 700 megahertz spectrum. There's a company called Access Spectrum that owns the 700 megahertz, and they sublease it to individual operators and organizations. If you go to their website, you can see information about where the spectrum has been allocated and sold. And it's again, it's two 1 megahertz channels. I'll go back here and show this: 757 to 758 and 787 to 788. And you can get today up to 250 kilohertz channel allocations from them, and they'll cover a particular geographic area. So that's the last question I have on the inbox here. Is there any last-minute questions that anybody has? I do appreciate we had great attendance today, and I appreciate everyone joining. And as I mentioned, there'll be a lot more information to come on the website. There's spec sheets, brochures, all of the data about the individual products. And then I mentioned that the product is available for ordering today, and will initial shipments will start in September, at the end of this month into the beginning of October. Okay, that looks like all the questions. Once again, I believe we recorded this session, so if you wanted to check back on something, or if you wanted to pass this on, Colin, I think we'll have this posted somewhere. Okay. All right, thanks again, everybody.